So as I said, we will give an overview over the project, and then I will hand over to Akhilesh, and he will present our ontology development part in that. So the DIGITRUBBER project the goal is to provide support for production using digital assistance systems. And the focus is on rubber production with a stronger focus in the extruding step. So the approach that is followed in the project is that data is recorded before, during, and after the process. And this data are used to identify material-dependent processing windows via suitable control algorithms to then basically adjust certain settings and parameters in the process to get the ideal output. There are several project partners involved. The ITA is responsible for developing the AI approach, that's data mining for optimizing the cross-process control. So it's a machine learning approach based on training data sets and on live data from measurement technology, and that measurement technology is being developed in the project. And it doesn't use ontology terms, this part of the project. Then we have the different measurement technologies that are being developed by different project partners. One is for photogrammetric 3D measurement technology for deformation analysis of rubber extrudates. Then we have one for geometry measurement technology for deformation analysis of rubber extrudates. Then we have one for materials analysis based on laser-induced plasma spectroscopy on the conveyor belt. And then, of course, we have to also control the machines, the settings in a live form within the running process. And that involves all these sensors and then setting the controls at the machines. So here we have the entire prototype that is housed at DIK with all the different measurement technologies applied. And also here, no use for an ontology. Then we have somewhat like a side project. One project partner is doing a profitability simulation, simulating the economic efficiency of manufacturing lines and that can only be in an exemplary way. So they looked at two use cases. One was in collaboration with Continental, I think, for tire production. And the other one was the use case in DIK with our prototype. And also here again, it was a side project. It was not directly connected to the rest of the project. And they also did not use ontologies. And then ourselves, who were with the project partners in collaboration with them developing the ontology, that is only used for annotating an existing relational database that is housed in the DIK. So it's a really a low-level ontology development. We have no axioms developed because they are not used. There's no reasoning involved. It's controlled vocabulary with human-readable definitions. And now I hand over to Akhilesh.
Hello. Yeah. Am I audible?
We hear you, yes.
Okay. Yes. Hello, everyone. Myself, Akhilesh Vyas, and I am working with LAS for the ontology development as a ontology development engineer. Thank you very much, LAS, for providing the nice overview of about DIGITRUBBER project overview. Now, I will provide the detailed overview of the DIGITRUBBER ontology development. So basically, It is an application ontology which provides the answers to semantic artifacts to answer the needs of the rubber extrusion processes. So here we used a hybrid approach for the development of the ontology. So which compromise first step is like identification of reference ontology, which already have some existing concept and terms related to the digit rubber processes. And the second is the hybrid approach, which has both automated and the manual development parts. The first, the manual creation of the, in the first part, we create the tabular file, which is having the new term definitions and the term text file. So, and the finally, then second part, the automated workflow of using the ODK and robot tools. And finally, we have the ontology editing using the TIB web services. I will cover all the topics in the details in the later slides. So next slide. Yeah. So this is a diagram for the ontology development pipeline. So pipeline starts from the competency questions on the left, and it has both manual and the automated components. In the pipeline, we have in the pipeline we have competency questions from the different project partners, and then we have the seed selection from the competency question, and then module extraction from the reference ontology, which has the seeds text file. And below we starts from the template, having the term definition template created by also the project partners. Later, we merge module extracted and template generated all files. And finally, we edit it using the CIB web service and push it into the GitHub repo. I will explain all these parts in other slides. So slide others, yeah. So in the competency questions, we have general questions about the application ontology and the use case questions. They are prepared by our project partners who are some are domain experts and some are use case owners. Here you can see the few examples. Later slide. Yeah. So what is the Raman spectrum of the raw rubber sample, and what are the chemical ingredients in the recipe X? So you can consider that the seeds are collected from these competency questions like Raman spectrum and raw rubber or rubber sample or sample. And what are the chemical ingredients in the recipe X? So chemical and chemical ingredients or ingredients and recipe. So these are, you can say, the seed terms. Next slide. So here are the some examples which we collected from the project partners for the competency questions. So in the first column, we have the competency questions and user stories, and then we have the priorities and the relevant work packages and the data inputs, which we are going to cover with the ontology, but we are not covering here, but it's just ontology. So later slides. So the first part is the seed is a selection. So it is a set of terms should be extracted from the source ontologies into the project ontology. So seeds comprise any terms and terms with the children or maybe selectors. So selectors can be ancestors, or it can be descendants, or maybe the all children's. So some examples are there in the next slide. So here are some examples from the DIGITRUBBER ontology. So the terms, C terms are like plant process, processed material, and assay. And here I have also provided the GitHub link. If it is, I don't know if it is last can open it or not. Yeah. Yeah. So here in the text file, we provide all the seeds from the competency questions, which are already existing in the some reference ontology. So maybe you can use obi term.txt. Last, you can open it. Yeah.
Which one?
Obi terms.txt. So here are the seeds actually. So which I showed in the example. They have the labels also in that my example, but it here it is not. So in the next slide, actually, yeah. So module extraction. So you can go next slide. So module extraction is the process for selecting an appropriate subset from an ontology. There are many ways to extract the subset from the ontology. So first method is like logical modules, SLME, which allow you to extract not only all the terms in your seeds, but all other logical axioms also. So that will impact the reasonings actually. And the second process is like using the robot filter. So this first select the entities in your seeds and then selecting the including and excluding the descendants and annotations. And the third is like mirrored. That is a technique which will extract the terms and their subclass relationship without any attempt to include other kinds of axioms. So here in this file, in this diagram, you can see we have import um, start.txt. Here we have the seeds actually, and we use the ODK robot tool to extract whatever the relevant parts from the terms actually using different techniques like mirror and SLME and put it into the all file. So the final version will be the all file actually, which will having according to your requirement all children's or maybe like descendant ascendants or any only annotations of the these terms. Next slides. So the next is the template. That is the another pipeline actually that starts from the lower, the template. Maybe you can go in the next. Yeah. So templates are basically for the people who have the very limited knowledge about the ontology development and its tool. So the first part is the header. This first row represents the column names in the human readable format. So you can provide any names to the first row actually, and these used to make the error message more useful when you are generating the ontology file from this. Uh, so second is the second row actually that shows a template string for the each column that will be used in the all conversion like the like entity type like class will be the all class or labels will be the RDF labels and superclass will be the RDF all class or like this. uh, and the last is in the third row and onwards, we have the data about the terms actually. So in the next slides, you can see the example of the template, which we created with the terms. So this is in the first column, you can see we have the classes actually, that is subclasses. And we also provide the subclasses with that. We provide the definitions in German, English. If we, Lars, you can open the full, the template with the terms like full CSV file then, yeah. So here is the full complete file actually. So you can see we have subclasses, then the labels in English and German. Then we have the parent class, where they have the definition in English and German. So Lars, can you go right little bit? Right.
No, I can't for some reason. I don't see any movement here. There's no bar to move left and right.
Okay.
Maybe I can go like this. Oh yeah, okay.
Yeah. So we have the definitions and it is, yeah, we can leave it actually. So we can go to the
This is Hank. You
slides
could go
again.
to the, sorry, you're mixing already. Okay.
Okay. So the next part is the merging and cross processing. So in the merge steps, actually, we merge the different pieces and the components from the different steps. Like the we have two steps here. Actually, one is going the upper pipeline and the lower pipeline. So we merge both the into the one file. And later in the post processing, we do the restructuring to remove the obsolete classes and provide the additional links and metadata and providing the title, description, and license to the ontology or other metadata which you use for the ontology. or also the annotation version information to the merged file. So next slide, Last. Yeah, next slide. Yeah. So now we have this ontology development kit. So this is the part which do all these things automated. So this is the open source tool actually, and it contains different set of tools for the each task. So we have many tasks when you release the ontology, like release, dependency check, quality check, reasoning, merging, and template components, and like module extraction. So there are many parts. So there are different tools are available in the ODK pipeline which you can use for that. And and you can also do the version control. And in the next slide, yeah, so this is our ontology pipeline configuration for the project. So here you can see when you start the project actually, so you need to define the configuration file for your project, which will have the the rows like from 1 to 9. You can say it's like about the metadata about the ontology, the repo, and the different things like the reports and all these things, like. And then the 10 to 12, the exports format, in which formats you want your ontology actually, all OBU, or maybe it can be TTL also. Then we have the reasoner also here in the like 15. You can define the reasoner if you have any consistent, if you want to have any consistency check actually for that. Then the line number 21 to 25, that is the part actually we are doing the module extraction. Here I have provided only few files actually, few lines actually. But if you go into the details, then you maybe in the next, Lars, can you open this ontology pipeline configuration part? Yeah. So here, this is our file actually. So this is the complete file. Lars, can you go down? Yeah, so here you can see all the products. That is a module extraction which we have done. And some places we have provided the module type custom. So it means like we in the seed selection, we are providing that in the text file, that in the text file we are providing all the seeds, so that it will take only that those yeah. And in the later part, if we go last down actually in the components, so that is the component which we are creating from our this template file, where we have defined all the terms definitions. Yeah, again on the slide actually. Yeah, so finally when you do all this merging and post processing, so you will have uh, the version which is generated using the configuration file, the all version of the ontology. And then we yeah, so maybe Lars, can you open this DIGITRUBBER ontology link? Are you able to open? Yeah. No, actually. Yeah, this is the documentation actually. Yeah. No. Can you go on the slide? Can you open the web protege actually, Lars? Which provide like the service actually, TIB service? Yeah. Yes. Mhm. So this is the file actually which we push into the TIB using the TIB web service. That is the instance launched by the TIB services. And here we provide all the things, and we have also the ontology metadata here in this. But it is currently it is having some bugs, so it's not able to. Yeah, cannot see it. And if you go to the home, Lars, can you go home? Yeah, click on that home. Yeah. So when you do editing of the ontology, different partners can. So here in the modified, in the right hand side, can you click on this three arrow, three lines actually? Yeah. It is showing, yeah. So here, when you do editing of the ontology, you can push actually to the repo. So you will maintain all the versions of the this. So can you open also? Yeah, git and commit. Yeah. Okay. Maybe you can show in the slide. I have in the slide in that yeah picture. Yeah, in the back side. Yeah. So here you can say you can edit the ontology. You can share it. Actually, it's a collaborative tool. You can share it. You can track the project changes and revision history, and you can also provide the watches and email notifications. And it also supports the Git, so you can see the commit and push project. So here you can provide the branch, and then you can have the new branch also. You can provide the relative part in the repo where you want to push this ontology, and you can also provide the format in which format you want to, and you can provide also commit message. So you will, whenever you are doing any changes in the web protege with the ontologies ontology file ontology, then you can push your changes there and you can maintain the versions. Yeah, in the next slide. So the lesson learned is that we think that, yeah, so all the project partners should be trained, should have the understanding and must be trained for the semantic topology like RDF, online shapes, and sparkles. So it's very easy to develop the ontology. And the second thing is that, like when you are developing the ontology, so there are always the questions that we should always think about what is the intended use of the ontology. And uh, and also we need to think about how we can consistently we can manage this ontology. Yeah. So thank you very much for your attentions, and now I am open for the questions and answers.